copy of that. Second, you can minimize the GoToMeeting panel. You notice that it takes up quite a bit of your desktop, but if you hit the, not the X, but the two arrows next to the X, it'll minimize it. And it won't take up as much of your screen space. Did you do that? Okay. Now, let me take a screenshot of this and I'll be able to write on your paper directly. So, we're going to begin at 3, correct? Remove the parentheses and subtract like terms from like terms. So first of all, what do you get when you remove the parentheses? I'm going to write whatever you say. Do it term by term. Got 2 minus signs in a row. In other words, this negative sign right there has to be distributed to the positive 5, and it has to be distributed to the negative 7i. Well, when you distribute it to the positive 5, you get negative 5. When you distribute it to the negative 7i, you get plus 7i. That's the mistake you made on every problem that you brought to the table in our last 2 sessions, is you did not distribute that negative sign to everything inside the parentheses. Remember the way to handle this. When you are subtracting, the best way to do it is by changing that to a plus and changing the sign on everything that's inside the parentheses. And that gives you your answer right there. When you have a plus and a minus next to one another, that's a minus. So it becomes 2i minus 5 plus 7i. Now combine those. What do you get? Oh, excuse me. I said no. This is the standard, lower right, this is the standard format for a complex number. You want the real part first, plus or minus, that's the coefficient of the imaginary part. So what are we going to end up with here? That's always going to be your answer. Nobody's ever going to put that as 9i minus 2. You will not see that as a multiple choice answer. You'll see what we have. In other words, this is called standard format, where your answer is in A plus BI. And that's the way you always want to put all your answers. Okay, we doing odds only? Okay, let's look at number 5. Remove the parentheses. Tell me what you get. Simplify? That's good. That's really good. Now simplify. So that you end up with A plus BI format. You want the real, A is the real number. That's the imaginary number. BI is the imaginary number. So what's the real number here? Add up all the real numbers you see. Now combine all the imaginary numbers. That's the answer. Notice that's in A plus BI format. Number 7. Looks to me, yeah, okay. Remove the parentheses. What do you get? Combine. Good. That's the answer. Are you on earbuds or are you on your speakerphone? Okay. Is the audio good? Okay. I'm on my earbuds. This is the first time I've ever actually used my earbuds in a tutoring session. I like it. It's almost better than my microphone that I'm used to using. Okay, so what else? 9 next. What's the line through 9? Are we doing odds or evens here? Odds? Okay. So all I got to do is multiply these together. What do you get? Distribute the minus 3i to both terms. What's I squared equal to? Okay, so what's minus 21i squared equal to? There's your answer. So the secret with most imaginary complex number problems is recognizing when you can convert a complex number into a real number. And about the only time you do is when it's I squared. You just got to remember that I squared is -1. That's all. And wherever you see I squared, substitute -1. That's pretty much all you have to remember. Imaginary numbers are actually quite easy. Okay? Let's do number 11. Foil those two, or ET-ETM. In other words, every term by every term. Okay? Good. Now, you can do all this in one step, or you can do it in 2 steps. If you think you can do it in one, I would say do it in 2 steps. In other words, convert that to a real number and combine those two. I would say that's the next step. So what is that? So minus 15. Now combine the 2 terms in the middle. Hold on. Minus 5 plus 12. That's 7. 7i. Plus 7i, okay. And then what's the right circled? What's 4i squared equal to? Now combine that for a final answer. There you go. That's the technique you're going to use for all of these problems, every single one of them. Okay, now, I promised you, we'll get back to these problems, but I want to show you something else. I mentioned it to you in our second session, and I want to show you how to take advantage of it. And I can see that, especially if you want to be a math teacher, you need to get greater skill at this. I want you to go as fast as you can. Give me your answer. I'm going to write it down. It'll automatically present you with another random problem. What's this? Go ahead. Next. 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 How come you're so much better here than you are when we're doing equations? Well, let's keep going. I want to make sure you're this good. Go ahead. I want to see you do a bunch of them. Keep going. Keep going. Keep going. Keep going. All right. I was going to ask you to copy and paste this website, but you don't need it. You don't. You're great. You're as good as anybody I've ever encountered at that. You're almost as good as me. That's what I'm great at, is those kind of. What we just looked at was single digit by single digit, positive and negative numbers, addition, subtraction, multiplication, division. You've got to be perfect at that to be good at math. You just do. There's no way around it. Even in the age of the calculator, does not make up for being able to do that in your head. You've got to be able to do it. And you were able to. Very impressed. Let's go back to our problems. Let's see. First of all, we got about 10 minutes. Do you have another page beyond this? Or is this it? Okay. Let me give you the hardest one on this page that I see. Let's do 19. Tell me how to do 19. Actually, I'd rather you not do it that way. I'd rather you verbalize it and look at my screen only and tell me what 2 plus 3i squared means. What does that mean, first of all? Okay, so it's 2 plus 3i times 2 plus 3i, which makes it the same as every other problem on this from 9 to 20. Let's just do it. Go ahead. Simplify. Simplify further. Oh, 4 minus 9. Okay, you're combining those two terms. Okay, go ahead. All right. Do you see why I'm surprised you missed that? Because if we were on that previous page and the problem was 4 minus 9, you'd have never missed it. I know how quickly you were answering those, that you are perfect at them. So for some reason, when you get them into an equation or a relation, it gives you trouble. Shouldn't. Just exercise the math skills that you know you have. 20, pretty much just the same as 19, only different complex numbers. Okay. Is there any on this page that you think you might have trouble with? Any, from 9 to 20, odd or even. They pretty much all look the same to me. You're going to FOIL all of them, or ET, or distribute, whatever. They're all multiplication. Okay, let's go to a new page. Have you sent me a new page yet, or do you need to do that? Go ahead and do it. We got 6 or 7 minutes before I have to go. Best way to do these online sessions, Jacob, is to send me the material before the session. Okay? Just so we don't have to waste time doing that, especially in a 30-minute session. A 30-minute session, you can't waste too much time or else you don't accomplish much. But, so if you think, if you schedule a 30-minute session and you think that's at least 2 pages, go ahead and send them both pages to me in advance. And then I'll have them when we start the session. DA are the first 2 initials you want to type in sending that. Okay. See how many seconds it takes to get to me. Not very many, about 10. Still doing odds? Are we still doing odds? Okay. Division. What we did in the last section was multiplication. Now we're doing division. Well, guess what? We're really not doing division. When you divide by a complex number, you're not really dividing any more than if I gave you this problem, 2 divided by square root of 3, you're not really dividing that. What you're doing is going to rationalize the denominator, right? You're not dividing. You're going to multiply. Everything is multiplication. That's your answer. It's not a division problem. It's a rationalizing the bottom, the denominator problem. Okay? Same thing with imaginary numbers. You're never dividing here. Not once. What you're multiplying by is the conjugate. That's the conjugate of 3 minus I. And since I got to do the same thing to the numerator, because I can only multiply by 1, now tell me what that answer is. What's the top? What's the bottom? Notice what the bottom is. I'm going to say this over and over again because it's so valuable. That's the difference of perfect squares factored, is it not? 3 minus I times 3 plus I. So if you put it back together again, you get a squared minus b squared. A squared is 9. What's b squared? Exactly. In other words, if you recognize that as the difference of perfect squares factored, you can multiply it together much quicker. You don't have to FOIL it. You don't have to ET it. You just know that it's this term squared minus this term squared. That's the difference of perfect squares. Now, what does all of that become? We still have the numerator. What's the denominator become? Simplify that. We're dealing with all even numbers. When you have nothing but even numbers, you can always simplify, because you can always divide by 2 at the worst case scenario. Divide everything by 2, what do you get? No, you got to divide everything by 2. You got to divide both terms in the numerator by 2, and you got to divide the denominator by 2. No, that's not -1. That's not I squared. That's I. That's your answer. In other words, you always have to simplify. Now, they said express the result in standard form. This is not quite standard form. This is standard form, a plus bi. How do I express this result in standard form? No, not really. What I need to do is break it up into the 2 fractions. That's the real part. That's a. That's the imaginary part. In other words, whenever you have a single denominator and you have multiple numerators added or subtracted, you can always break it up into fractions. So that becomes 3/5 plus 1/5 I. I could have written that as I divided by 5, but if I'm going to put it in an a plus bi format, I need an a and a b. Well, there's a, there's b. A is a real number, 3/5. B is the coefficient of the imaginary number. But the correct answer is that only, because she wanted it in standard form. Always remember that a plus bi is standard form. So whenever you do these problems involving imaginary numbers, you don't get it in standard form usually. You get it in this 3 plus I divided by 5 form. So you're always having to separate this into 2 fractions. Okay? It's 3 o'clock, unfortunately. I'd like to do one more just to make sure you can get it all the way to the end, but I think you understand. Okay? Now, I've been recording this and I want to send you that link. So, did you put in the email address that's a good email address for me to send it to? Okay, I'll use that email, whatever you signed in with, I'll use that as the email address. And as soon as this file, this recording is processed, I will send you a copy of it. Okay? Pretty cool, isn't it, this online tutoring? Yeah, is it any different than in person? I mean, it's no worse, is it? It's got to be nothing but better, I think. I don't know. I'll let you think about it for a while. Tell me next time we talk. All right, Jacob. You have a good rest of your day. I'll talk to you next time.